Hi guys. Today we're going to learn about solving and graphing inequalities. An inequality is something that is not equal to a given expression. So let's see how we could show these inequalities. There's 4 different ways we can show inequalities, and these has similar but not quite similar. You'll see why. I'm going to give you an example. Let's see, I have this inequality sign that is greater than. If I put a number 5 here and I say 5 is greater than 4, that makes sense. But 5 is greater than so many others. For example, 3, 2, 1, and it goes on forever because numbers are unlimited. So 5 is greater than 4, yes, but 5 is also greater than these numbers. So there's a set of solutions. Now this is a new word that you are going to learn today. Solution set. Let's try to understand what this means. Solution means an answer. A set means it's more than one. So solution set means more than one answer. And as you can see, there's 4, 3, 2, 1 in this example. That would make this inequality correct. In other words, that would make this inequality statement true. So the statement has to be true. A true statement. That's what I want. Okay? So let's try one more thing. I can say 5 is greater than 4, yes, 3, and all that beautiful stuff. But there's this equal sign. So now I have to put 5 is greater than or equal to 5. Previous answer did not have a 5 because it's just greater than. This solution set includes 5 because it has the equal to sign. And it goes 5, 4, 3, 2, 1, dot, 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 curly brackets. So my solution set is always shown with curly brackets, a few numbers inside separated by a comma, usually 3 numbers, and 3 dots. Not more than 3, not 2, not 5, 3 dots. That's how mathematically we show that there's infinite amount of solutions that would make this statement true. Let's do a quick example again. So 5 again is less than, I could say 6 and 7 and 8 and dot 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 curly brackets. Now I have a solution set because that's what actually would make this statement true. I cannot just say 5 is less than 6. 5 is less than so many. And so forth goes to the other side if I had a different number here. Like for example, I could say 5, 4, 3, and dot dot dot. Actually dot 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 should be over here. Curly brackets, that's an ugly curly bracket. I do not like ugly things. Okay, there you go. So I could say 3, 4, 5 dot 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 is less than or equal to 5 on this side. I have to say 5 because 5 is here. So 5 has this solution set makes this statement true. That's what we need. Moving on to the next one. Let's actually graph an inequality to see how it works. What are the numbers that satisfy this inequality? In other words, what is the solution set that would make this statement true? These are the vocabulary that we're going to be using today. So if I had x is equal to 3, how would I graph it? I would say in my number line, figure out where 3 is, put a dot, and I'm done. X is equal to 3. That's it. Inequalities, since we have more than one solution, we have to show that in our graph. We have to show that there's more than one solution. So we want to graph x is greater than 3. Now I'm going to give you guys a few seconds to choose A or B, which graph shows x is greater than 3. Pause the video, please go check, think about this, and then tell me an answer. Is it A or B? Okay? Alright, so if you said it's A, then it's correct because x is the unknown. We don't know what is in x, but it could be anything because there's infinite number of numbers, integers that's greater than 3. For example, 4, 5, 6, and so forth until infinity. So all these numbers can be true, and all these numbers live on this number line at this starting point. 3, 4, 5, 6, and so forth. So I have to choose A as my correct answer that shows x is greater than 3. In this graph, x is less than 3. Look at where the circle is. 3 is the circle, 2, 1, 0. These are all numbers less than 3. So I have to say this is the one that shows x is less than 3. But for my question, it's x greater than 3 is A. Okay, and when I'm showing my number, especially if it's x is less than 3 or x is greater than 3, I have to make sure that the 3, let's say this is 0, the 3 has an open circle on it. It should not be colored. Okay, it should not be colored. It should be an open circle, as you can see in this figure. Let me show it clearly. It's an open circle here. Moving on to the next one. Let's do an example. Graph the inequality to show the numbers that will satisfy. Okay, I want my ruler. Let's draw a number line. So y is greater than 14. I'm going to make my y is a 0 and a 14. These are the two numbers that should be on your number line if you have a simple inequality like this. Y is greater than 14. All the numbers that are greater than 14 should be highlighted. So all the numbers that are greater than 14 lies on this side of the graph. So I have 14 is open circle, and my numbers are 15, 16, 17, and so forth. Let's check out a number from this solution set. Let's say 16. I'm going to substitute 16 for y. 16 is greater than 14. Is this true? Yes, it's true. So this number set is correct. This solution set is correct. Okay, let's take a number just to see what we're talking about. Let's take a number that's not in this solution set. Okay, let's take a number, let's say 1. Now I'm going to substitute 1 for y, and I say 1 is greater than 14. Is this true? It's not true. It's never going to be true. So it's wrong. So this is in the wrong side, and we have chosen a wrong side, wrong number. So that means all my solution sets should start from here and go this way. If it's reducing and the number statement is not true, then we have chosen the wrong side. That's a good way to check your answers. Okay, let's do one more. I have this. T is less than 7. So I have a 0, I have a 7. Which way should I highlight my numbers? If you said this way, then you are right. So what number solutions would be making this statement true? 6, 5, 4, and so forth. So if I chose 3 and I say 3 is less than 7, that is true. So let's take a number greater than 7 to see if that makes sense. Let's take a number that is not in the solution set, say 11. So I'm going to substitute t for 11. 11 is less than 7. That's not true. So we know we have chosen the right section by doing this. Okay, 11 is not a solution or not part of the solution set for this. Let's do another, and this should be easy for you now. I have r is greater than 12. So take a moment, pause the video, sketch this on your notebook. I know you have a notebook with you when you're doing math videos. So sketch this on your notebook and see if your answer matches mine. Okay, just pause the video. Okay, so if you said this is your answer solution set that goes this way, then you're correct, because everything that is greater than 12 will make this statement true. Alright guys, so let's try to solve an equation and an inequality. How do we solve an equation? By doing the inverse. Okay, that did not look like inverse. Inverse operation. What's the inverse operation? It's the opposite operation. Why are we doing this? To isolate the variable. Okay, let's do the inverse operation to this equation here. What is the operation? Plus 6. What's the first step? Do the inverse operation, which is minus 6 on both sides. This cancels each other. 6 minus 6. Y is equal to 21. Okay, we have a solution for this equation. Let's see what do we have here. Y plus 6 is greater than 27. Now this is an inequality. To solve an inequality, we have to do, ta-da, the same thing. Inverse operation to isolate the variable. Let's see how this is working. So y plus 6 is greater than 27. Now to do the both sides, this is my both sides, where my inequality signs separate the sides. Okay? So both sides means I have to subtract 6 from this side, subtract 6 from this side. What do I get? Y is greater than 21. See the similarities and see the differences. Similarities, differences. Y is greater than 21. Let's graph y is greater than 21. Okay? So I have 0, 21, and what should be your answer choices? Y is greater than, so I have to give my circle on 21, open circle, and all the answer choices that's greater than 21 will fit or will make my statement true. So let's see if this works for my original inequality. Let's take a number that's greater than 21, for example 22. Let's say y is 22. I'm going to substitute 22. 22 plus 6 is 28 is greater than 27. Perfect. Works fine. Let's check one more. Let's check 20, because 20 is less than. Now we're doing something different, not from the solution. We're taking something different, not from the solution set. So we'll say 20 plus 6. 20 plus 6 is 26 is greater than 27. Now we all know that is not true, so that means the solution set should be on this side, and that's correct.